CBSE Class 10 Math, we are discussing sample question paper solution. This paper has been given by CBSE for the year 2021. Two variants of paper exist, as you all are aware. This one is a basic variant. We are going to be looking at the first 4 questions, of which question number 3 has got an internal choice. So, in total we will be discussing 5 questions in this video. Right, let's get started. The first one, again all of these are 1 mark question. So, time it should take us is probably 1 minute to solve each of these questions. Express 156 as a product of primes. Let's get started. 156 is an even number. So, let's start dividing 156 by the smallest prime that we know, which is an even prime, which is 2. So, 156 divided by 2 is a 78. 78 is again even, divisible by 2 gives us a 39. 39 is an odd number, not divisible by 2. Let's check out whether it's divisible by 3. Yes, 3 divides 39 to leave us with 13 as the quotient. So, how do we express 156 as a product of primes? 2 times 2, which is equal to 2 square times 3 times 13 is how you express 156 as a product of its primes. Quickly recap it in half a second in a printed form. So, basically 156 prime factorizes, divided by 2, 78, divided by 2, 39, divided by 3, 13. So, final answer is 2 square times 3 times 13. Let's move to the second question. Second question, write a quadratic polynomial, sum of whose zeros is 2 and product is minus 8. Sum of zeros given, product of zeros given, it's a quadratic polynomial. So, how do you write the polynomial? Basically it comes from this. A quadratic polynomial whose sum and product of zeros is known is x square minus sum of zeros times x plus product of zeros is how you basically from the sum and product of zeros you find out the quadratic polynomial. What's the sum? Sum is equal to 2. What's the product? Product is minus 8. So, just plug in those values. X square minus, instead of sum I am going to write it as 2, 2x, instead of product I am going to write it as minus 8. So, the required quadratic polynomial is x square minus 2x minus 8. Quickly recap it again in a printed form. What is given to us is the sum of zeros. If the zeros are a and b, sum is equal to 2. If the zeros are a and b, the product ab is equal to minus 8. So, how do you find out the quadratic polynomial? X square minus sum of zeros. Keep that in mind, it is minus sum of zeros times x plus product of zeros. It works out to x square minus 2x minus 8. So, question 2 done. Let's move on to question 3. It's got internal choice as I had mentioned. This question deals with one particular idea about LCM and HCF. If you have two numbers a and b, you would have probably read this rule. Product of these two numbers a into b is equal to the product of the LCM of AB and HCF of AB. That is what is tested in this question. Let's quickly run through the question. Given that HCF of 96 and 404 is 4. So, what is given? HCF is given to us. Find out the LCM of these two numbers is what they have said. I will write this rule and then get started with this. Let us say the numbers are A and B. A into B will be equal to LCM of AB into HCF of AB. What all are known to us? A and B are known to us. The numbers are 96 and 404. So, let us write that first, 96 times 404. Don't make the mistake of computing it at this stage, right? When required, we will compute it because things on the right hand side might cancel with this. LCM is what we need to find out. What is given? HCF of these two numbers is given to be a 4. So, we will have to find out the LCM. I will just write it as LCM times 4. Can we divide both sides by 4? Certainly yes. So, we divide the right hand side by 4, I will be left with an LCM. The 404 will cancel with 4 to leave us with 101. So, this is 96 times 101. It's a very lovely easy calculation. 96 times 100 is 9600 plus a 96, which is equal to 9696. This is what we need to find out, right? You write this rule, you get half a mark. You compute the answer, you get another half a mark. Quickly summarize it in the printed form. The key concept is HCF into LCM is equal to the product of the two numbers. HCF is known, which is equal to 4. So, LCM is nothing but the product of the numbers divided by 4, which is equal to 9696. The next one is basically you know a rule, you can write the rule, you got the answer, right? The rule that we are talking about is basically the fundamental theorem of arithmetic. I will read the rule in the next slide. What it essentially means is you can prime factorize any composite number in only one way. Prime factorization of a composite number is unique. Only that the order in which you write the prime factors, that could change. That's what this rule is. If you write that, you get a mark. Quickly run through this rule. The rule basically is every composite number can be expressed as a product of primes, and this factorization is unique. The moment you write this, good enough, you'll get 1 mark. Complete it, it's good, right? Apart from the order in which the factors occur, right? If you write this, you get a mark, or if you're not sure about this, 3A was an easy question too. So one of these two is what you were expected to do. The last question for this video, on comparing the ratios of the coefficients, find out whether the pair of equations x minus 2y equals 0, linear equation, and 3x plus 4y minus 20 equals 0, is it consistent or inconsistent? How do you figure out whether a given pair of linear equations, they are consistent or not, right? Let's write a generalized form of linear equations. A1x plus B1y is equal to C1. A2x plus B2y is equal to C2. Two linear equations, if they are in this generalized form, the equations will be consistent when A1 by A2 is not equal to B1 by B2, right? Let's check out whether that works in this particular case. Is A1 by A2 not equal to B1 by B2? First equation is x minus 2y is equal to 0. So A1 in this case is 1, B1 is equal to minus 2. Second equation is 3x plus 4y minus 20 equals 0. We'll write it as 3x plus 4y is equal to 20. So A2 in this case is equal to 3, B2 is equal to 4. So got A1, A2, B1, B2. Plug that in here. A1 by A2 is a 1 upon 3. Is it equal to B1 by B2, which is minus 2 divided by 4? This is a minus 1 by 2. 1 by 3 is a positive number. This is a negative number. Definitely is not equal. If A1 by A2 is not equal to B1 by B2, then this pair of linear equations is consistent. That's what is the answer, right? So you write this rule, you get half a mark. You express this, you get another half a mark. Quickly recap it this particular question also in a printed form. For any pair of linear equations, a1x plus b1y equals c1 and a2x plus b2y equals c2, they will be consistent provided this condition is satisfied. You are expected to know this to solve this question. a1 by a2 is not equal to b1 by b2. So first equation, a1 equals 1, b1 equals minus 2. Second equation, a2 equals 3, b2 equals 4. a1 by a2 is equal to 1 by 3, b1 by b2 is a minus 1 by 2, minus 2 by 4. It is not equal, therefore this pair of linear equations is consistent, right? The next video, let's look at the next 4 questions. Till then, good luck.